any numerical attribute.
Profit loss.
Say it again.
Profit loss.
Distance. Okay. So that's correct. Profit or loss. Thank you. Another point to make is for discrete attribute is when it has, yes,
Good question. In the previous one, shouldn't street number be a nominal attribute? Because usually the operations we perform with street numbers are, is this street number 5? Not is, and not, is this street number greater than 5? So shouldn't it be nominal instead of?
yeah, that's an excellent question. So think of it this way. The street number is a number. It's a numerical attribute. So nominal is when you have some string, basically like eye color or silver, bronze, or yes or no, or maybe. Usually a word. When it's a number, then that usually is not nominal. So that's a numerical attribute. That's why it was shown in the ratio. So what's the difference between discrete and continuous? Does anybody know? Do we have okay, so before we can store anything in the computer, we have to make it discrete. So in the real world, we have continuous values. When we want to store them in a computer, this means they have infinite amount of information. If we want to store them, we have to make them discrete, which means sample the value of particular times and choose certain values that we want to store, because we don't have infinite amount of memory in the computer to store infinite amount of information. Neither we can send it through the network because it also has a bandwidth on it of the amount of information that it can send. So if we think about continuous attribute, this is, let's say, temperature. So take the temperature from here. So the temperature will change very slowly. Let's say 60 degrees, 61, 62, 63. Now, we don't really care about all the numbers between 60 and 61, but they exist because in nature, when the temperature changes from 60 to 61, it has to go through all the numbers in between. So these are the real numbers. So let's say it's gonna be first 60.1, 60.2, 60.3, until it gets to 61. But then also all the numbers in between, 1.11, 0.112, 0.113, all these things. This is what happens in real life. The temperature will go through all these values until it reaches from 60 to 61. We don't care about all these numbers. All we care about, was it 60 or was it 61? That's enough information for us now. We don't need to be storing all that stuff in the computer. So unfortunately in nature, our voice, the temperatures, the lights, colors that we see, everything is continuous. So to make it digital, we're gonna sample it, take measurements at certain amounts of time, remove all the information in between that we don't need, and that's all we're gonna store. That's why we make it discrete. This means a finite amount of numbers. So naturally, the things that come from the real world, like temperature, height, and weight, would be continuous attributes. If the attribute has a finite amount of values, then it's called discrete, because we can count the number of values that it has. They're not infinite. Typically, the types of data, the most commonly are stored in tables like this, but we also have other types of data that we will look at. That could be stored in a graph, or they could be ordered in particular sequence. So typically, a lot of the algorithms that we will look at will work on data that is in a table format. So we have rows and columns, but also we could have data which it looks like a graph, like in data linked documents, or it doesn't have any structure to it. Let's say a bunch of text documents that are not related or linked in this way. And another type of data is ordered data. So let's say data that makes sense through time. What is the temperature now, or what is tomorrow, what will be the day after? So that's temporal data, because it has some order to it. If we switch the order, the data doesn't make sense anymore. So when we say graph data, then we have links from one point to another data point. Chemical data could also have some graph-looking structure to it. So for example, this is a chemical molecule, and again we have links between the data points or nodes. So going back to our subject of pre-processing. So we mentioned we'll talk about pre-processing because it's an important step in the knowledge discovery databases process. So some of the things that we mentioned we will do during pre-processing was removal of noise and outliers, and detecting missing values, and either trying to predict what these missing values are and fill in the values, or remove these records maybe that are missing the values, or make sure that algorithm can actually process records that contain missing values and not just crushing on us when we run the algorithm, the data mining algorithm. And finally, what do we do with duplicate data? So when we said noise, This means usually some value that is incorrect or it's way outside of range of the normal values that we have. So if somebody made a typo in the data, we mentioned last time, we gave an example with a person that was it 300 years old? The person was 300 years old, and that's recorded in the data. So most of our objects were between the age of 20 and 55, and then all of a sudden there was this guy that's 300 years old. So it's probably somebody made a typo when they typed the age. That's a mistake. That introduces noise. Into the data. So if this is the original data, this is data plus noise. So noise we will call something that is incorrect and it's impure and it's not supposed to be in the data. One way to detect that is to look for what's called outliers. So if we are to plot our objects in space, they will look like points. That's why we also call them points. So imagine like this is the x coordinate and this is the y coordinate. And there are some values of attributes here. So we plot the attributes. Most of our objects are here. We have some here and some here and another cluster here. But so it means most of our objects, let's say that this is the age attribute. So most of our objects are here, and let's say that age is like from 30 to 55. And that object is probably 100 years old. And it's way on the side here. And it's only one of them, like that. So when we see something like that, we can remove it from the data to clean up the data. This one and that one also are noise because they are just one of them very far away from everything else. So when we say far away, this means we can compute exactly how far it is by computing a distance. And we could set up some sort of threshold to indicate how far is the object from any groups of objects that are clumped together. So this, when we see an object that's very far away and it's by itself, it's probably an outlier and it's noise. So let's say this guy is very different from all the other objects. One attribute is on the x value, one is on the y, but they could be a lot more than that. That's if we only have two attributes. So x will be on the one attribute and y will be the second attribute. We could have x, y, z if we have three attributes. Then this will become three-dimensional. We will have a depth dimension, the third dimension. Now, doesn't matter how many dimensions we have. We can only draw three of them, x, y, z. But we could have 4, 5, 45, or 300. Doesn't matter. So the objects will still look like that when we plot them in space. And we have a formula to use all of the dimensions to calculate the distance between the objects.